Okay, so strap yourselves in, folks, because we're diving headfirst into the world of quantum computing.
Yep.
And not just any quantum computing. We're talking about Google's brand new Willow chip.
Right.
This thing is making headlines, and for good reason. Willow just solved a problem in 5 minutes.
Yeah.
5 minutes. A problem so complex that would take the world's most powerful supercomputer. Billions of years to solve.
Billions, yeah.
So today, we're going to try to break down why Willow is such a big deal, what it means for the future of, well, pretty much everything.
Exactly. It's a fascinating development.
It is.
And it really represents a fundamental shift in how we think about and approach computation.
So let's start with the basics, because we've all heard the word qubit.
Right.
But to be honest, I'm still a little fuzzy on how they actually make things faster.
Sure, I think a lot of people are.
Right.
So think of it like this. Your computer, the one you use every day, uses bits,
Okay.
which are basically like a light switch. Either on or off, 1 or 0.
Makes sense.
A qubit, though, is more like a dimmer switch. It can be 1, 0, or any combination in between.
Wow.
That's because it leverages this principle called superposition, which is a quantum property where particles can exist in multiple states.
At the same time.
At the same time, simultaneously.
Okay, so that means more options for each piece of data.
Exactly.
But how does that actually translate to, like, solving problems faster? That's the part where I need the aha moment.
Well, it's all about parallelism.
Okay.
So imagine you're searching a massive database.
Right.
A classical computer has to go through each entry one by one.
Yeah.
A quantum computer, thanks to this superposition principle, can essentially search all entries at the same time.
At the same time.
Now, Willow takes this even further.
How?
It uses a specific type of superconducting transmon qubit, arranged in this grid pattern that allows for really efficient communication and entanglement between the qubits.
Oh, interesting.
This design really speeds up computation and allows for the implementation of some very complex quantum algorithms.
Okay, I think I'm starting to get it. But then there's that whole issue of qubits being, like, super fragile, right?
Right.
Like a stray photon messes everything up.
That's absolutely a major challenge. It's called quantum decoherence.
Decoherence.
And any interaction with the environment can introduce errors.
So how does Willow deal with that?
Well, what's impressive is their error correction. They've implemented something called a surface code, which basically distributes quantum information across multiple physical qubits, creating a more robust, logical qubit.
So it's kind of like, it's like weaving a safety net.
Yeah.
To catch and correct those errors as they happen.
Okay, so we've got faster and we've got more reliable. I'm picturing scientists just drooling over this thing right now.
Absolutely, yeah.
But what are the real world uses of this? I mean, beyond just breaking speed records.
That's where it gets really exciting. So one major area is drug discovery.
You know, simulating molecules to design new drugs is incredibly complex. For classical computers, quantum computers like Willow could do this exponentially faster.
So potentially leading to breakthroughs in, like, treating diseases.
Exactly.
No more waiting decades for new meds. That's huge. What else? What else?
Materials science. Imagine designing materials with specific properties. For energy storage or stronger, lighter building materials, quantum simulation can play a huge role there.
That's amazing.
And then you've got these optimization problems like logistics, think delivery routes, supply chain management, stuff that has, massive economic implications.
So we're talking better batteries, greener shipping, maybe even figuring out traffic jams once and for all.
Right.
This is like mind-blowing stuff. But it does feel very future.
Sure.
Are we like years away from actually seeing this impact our daily lives?
It's closer than you might think, actually. Willow's achievements are really accelerating the field. While we won't have quantum computers in our pockets anytime soon, the technology is maturing very rapidly. And within the next decade, I really do expect to see quantum computing influence many aspects of our lives.
Wow.
From the medicines we take to the products we use.
It's almost like we've cracked open the door to, like, a new era of problem solving.
Exactly. And that brings up a really crucial question for you.
Oh, okay. Hit me.
Given Willow's ability to tackle these previously unsolvable problems, what other applications can you envision? What challenges in your field or even your daily life could quantum computing address? It's worth thinking about as this technology unfolds.
It's a lot to wrap your head around, but definitely worth thinking about.
It is.
Thanks for breaking it all down for us.
This is my pleasure.
This is exciting stuff. Really looking forward to seeing where it goes from here.
Me too.
All right. Thanks for listening, everybody. We'll catch you on the next deep dive.